Hello, in this video we will discuss data cleaning and screening, including various techniques and using Excel and Jamovi software. Some of the things we'll discuss is self-report data collection, direct screening, instructed items, bogus items, and much more. First off, self-report data collection. What is it? Well, self-report is when a survey is provided to individuals and they in turn read the items and reflect on their own, whether it be personality characteristics or perhaps how satisfied they are with their job and so on. And they report basically how they feel or how they interpret themselves and so on. Reasons for doing this is easy access. However, a challenge is a lack of direct observation by the researcher. They cannot actually observe the participants traditionally, if it's an online survey. Sometimes they may observe the participants taking the survey, if it's in a live setting. However, they cannot actually observe the behaviors. Present in a socially desirable manner is something that participants may often do. They may see themselves, for instance, as being a more effective leader than they actually are, so they'll present themselves in a more desirable manner according to how they see themselves rather than perhaps how they actually are. However, you can help prevent some of that bias from having others also report on the individual. It goes back and forth, but that is another conversation for another day. There's also no guarantee of reliability. In other words, participants may respond a certain way very quickly because they just want to get the survey done and so on, but that can be addressed, which is what we will go into now. We will address how you can screen data after it's been collected to see how reliable it is. Now, before you actually collect the data, there's another technique that will apply then once you collect the data later on, and that's to build into the survey design some things that will help us later on. So in other words, first off, self-report. Now, this is a little bit different than the self-report I just discussed, self-report of the survey. This type of self-report is used for data screening. And basically what it is you literally ask the participant if they occasionally, for instance, answered items without reading them, or how seriously did they take the survey, that sort of thing. And ideally, if they're answering honestly, they will tell you, yeah, you know, maybe I didn't read all of them or something. So therefore, you have more unreliable data. Another method of direct screening is instructed items, where you would inform the participant to do something specific, such as, please leave this item blank. Then what that does is if people are paying attention, they'll leave it blank. If they're not paying attention, they might enter something in there, or even if it's a bot, it's a computer program that types something in there, then you can determine that maybe it's unreliable data. And then finally, bogus items. For instance, I was born on the planet Earth, and they have to respond to that. Naturally, everyone, for the most part, as far as I know, is born on the planet Earth. And again, these are direct screening approaches, and they're built into the survey design before data is even collected. Another method is called archival screening. Archival screening is when you examine the data and you look for patterns in the response behavior. I have a couple examples here I'll discuss in a moment. So first off, semantic synonyms is where you have dissimilar responses to similar items. For example, if you have 5 items that are similar, that measure stress, and they're supposed to all basically get a similar scoring, and you have some very high scores and some very low for similar items, then it could be problematic. Semantic antonyms is where you have similar responses to dissimilar items. So for example, on that same measure of stress, supposing a couple of those items are reverse scored. So in other words, you would get maybe 3 items that a high score would be high stress, and 2 of the items, a low score, would be high stress. They're reversed. And so if they're all similar, but they're dissimilar items, then you know that it's perhaps unreliable data. Response time can also help you determine if data is potentially unreliable. SurveyMonkey, for instance, will provide the start date and end date as well as the time that the survey was started and ended. And if you glance through that amount of time and you notice that perhaps a participant only took like 21 seconds to take it, as in one of the examples here, then that's possibly an indication that it was either a bot or they just quickly went through it and completed it. And finally, long string responses is when, like in the example below, where they're all putting the same number, and that's possible, but it's also perhaps, depending on the survey, it might be improbable. Another method of screening is statistical screening. It is similar to what we just discussed, however you apply statistics, and you apply statistics to see if data perhaps is unreliable. So when you have psychometric synonyms, basically you're looking at similarly at what we just talked about. The synonyms will be items that are responded in a similar manner. I say positive inter-item correlations, meaning they're all going the same direction. And so when you analyze those using a correlation analysis on each participant, those then should achieve like a 0.60 effect size cutoff, where basically higher than that, they should be correlated. And so, but if they're all, let's say, they're all the opposite direction, so they could be all, let's say they're all positive one direction or negative one direction, but they should correlate together. To better understand that, we look at psychometric antonyms, where you're going to have negative inter-item correlations, meaning you might have some items that are reverse scored, therefore you're going to have positive and negative worded items, rather than the previous example, which they're both going in the same direction. Here you'd have different direction, therefore you would have a negative correlation, one going up, one going down. They're more complicated. These statistical procedures here are very effective. However, from a practical standpoint, they may be more challenging because they would need to be done on each participant, and there are ways to do that rather quickly. However, it's a bit more challenging. Now, personal reliability, that's also a very complicated approach, perhaps more complicated than you need. Other methods are easier and more time-consuming, and you can get those done with perhaps similar effectiveness. However, if you were to take this approach, you take scales, for instance, that are in the same direction, you divide the responses in half using the split half technique, and then you analyze those two sets of responses, and those should be similar. And then this Mahalanobis D is where outliers, the respondent, basically you have a respondent may have outliers, and you compare those to the sample mean, and if there are those significant outliers compared to the sample mean, it may be, again, some unreliable data. Again, another very complicated approach when other approaches may be just as effective. Here's a summary of what we just discussed. So again, self-report, instructed items, bogus items all fall under this category of direct screening. Semantic synonyms, semantic antonyms, response time, and long stream fall under archival screening methods. And finally, psychometric synonyms and antonyms, personal reliability, and Mahalanobis D is under statistical methods. Some examples of cleaning data. Here's an actual spreadsheet, part of a spreadsheet that was used in a study, and the data has been organized. So what you have is information on each of the items, meaning in this example, it says, I feel students blame me for some of their problems. You actually have the item as it was read when individuals took the survey. That can be for all of the items. So that way, in the future, if you were to look at the spreadsheet, you would know exactly what was asked of the participants. And then also have the scale. So in this example, 0 equals never, to 6 equals every day. There's also other examples of scales for demographics, like 1 equals male, 2 equals female, 3 equals other. You have this as well so that you clearly know what scale was used. And then this will also help later on as we move the data from the spreadsheet over to the statistical software. Labels would also be important here, so you know exactly what was measured. That can be perhaps abbreviations for each item, such as DEP5, meaning depersonalization, and it's the 5th item for that variable. Also, you can type out the variable names, such as exhaustion, accomplishment, depersonalization, or for demographics, age, gender, and so on. And then finally, you have under these variables, you may have to, because they're, let's say, the sum or the total of the items, or maybe an average of those items, then you would also do those calculations underneath the variables that you create. So this is cleaning up the data, also getting it all organized, finishing it up, calculating, and so on. Some other things you have to do to clean up your data is, first off, you may have incomplete responses. And if you do, if there is a significant amount of incomplete responses, then you may choose to discard those. And you may have a cutoff. For instance, if there is, let's say, only 2 or 3 items that are not responded to, you might use a different method called imputation, which I'll discuss in a moment. And then everything greater than that you throw away. But there's more logic to it. And I encourage you to search the internet for videos on imputation and learn more about it. You also look for outliers, box and whisker plot or a box plot. Here's an example on the left where you look for outliers. That box plot statistical software will commonly give you the participant number in your statistical spreadsheet, your software spreadsheet. So if it says, for instance, an example, we have participant 31, 63, and 33, we would go to those participants, review their data, and using some of the methods we already previously discussed, we would see if potentially that is unreliable data, and then we make a decision on that. So that's how outliers can be reviewed. Outliers are not automatically thrown out. They may be deemed that they are reliable data, and we keep them. Imputation, as I mentioned earlier, it's a way to manually insert data. If a participant, let's say they, out of 5 items that measure stress, maybe they just accidentally missed one. So what we can do is actually use a statistical procedure. It's not guessing what they might have put in there, but instead we use some basic math where we determine the average score of, let's say, those other 4 items, and then we would insert the 5th. Or we might also use mode, where it's the most common. So if 4 items were 1, 1, 1, and 2, rather than averaging those out, we might just enter a 1 for that 5th value. Correlation analysis can be used. We discussed that previously, where you look at the respondents' responses and actually correlate those. But another way of using correlations is, for instance, you determine if, for instance, if there was an item that was supposed to be reverse scored and it wasn't, well, if you run a correlation analysis on all of those items, what then you may find is one item is a negative value when they all should be the same direction. And if that's the case, then that one perhaps should have been reverse scored. Also, Chromebox Alpha can be used, where you analyze the data to see if the let's say the totals for each of the items are aligned, and if one is significantly different, then perhaps a scoring, reverse scoring, for instance, was not done properly. And that is something that I've seen many different times using both correlation and Chromebox Alpha, where students did not properly reverse code. And then finally, a scatter plot can be used just as a visual aid to see if potentially there's some outliers. However, the box plot tends to work much better for that. I also encourage you to look ahead. You can look ahead at Jamovi and see how some of these analyses are done. If you look ahead in future weeks, week 5, for instance, we'll have many different videos on how to use Jamovi and actually accomplish some of these statistical procedures. Thank you very much, and I hope you have a great day.